in the book, I didn't actually explain test of simple main effects using a graph. I showed you using a table. So test of simple main effects, if you're going in one direction, it means you are either comparing, the cells in a row, right, in each level of one row. Okay, so you have row 1, you're going to look at those means. Then you go to the next row and you look at those means. Okay, so they can be looking at means, comparing means within each row. Or in the other direction, you can look at how different the means are within each column. So a test of simple main effects then compares means one row at a time, or test of simple main effects compares means within one column at a time. I showed you by a graph, okay? In fact, let's go back because I think this will be helpful. Okay, so if we were comparing this one to this one, and then this one to this one, and this one to this one, that means we are comparing left to right. Okay, so we're looking at the effect of hemispheric dominance, but we're doing it separately, right? We're doing it for the 0 joint, the 1 joint, and the 2 joint. So that would be the simple main effect of hemispheric dominance, and then separately or within each level of marijuana. And that would just be a t-test. And if a t-test is significant, you don't do a post hoc test. So here we do an independent t-test, an independent t-test, and an independent t-test. The other direction was comparing the effect of marijuana, so looking at 0, 1, and 2, but separately or within each level of hemispheric dominance. So we're going to look at this group, and this group. Those are 3 levels of marijuana just for the left. And that would be a one-way independent ANOVA. And if that is significant, yes, you need post hoc tests to see which means are different from which. And then the last test of simple main effect would be, again, looking at the effect of marijuana. So we're going to be comparing the means of marijuana, but this time it's only for the right group. So it's these 3 blue bars. So that would be another one-way independent ANOVA, and we would need to follow up with post hoc tests if it is significant, if that one-way ANOVA is significant. Now, what if, let's play the what if game. And then I think we're going to have to stop. But what if it was the same people in each group? What if every group here was the same set of people? Well, I already said if you're comparing just 2 means, that would be a t-test, right? So if it's the same people in each group, that's a dependent t-test. So you would have 1, 2, 3 dependent t-tests. What about the ANOVA? Well, you'd still have 2 ANOVAs because you're going to compare green to green to green. But if it's the same people in each group, then it's a one-way repeated ANOVA. Same thing here. To compare the blue to blue to blue, in other words, all the marijuana levels, but just for the right hemispheric people, that would be another one-way ANOVA, but this time a repeated ANOVA. And if that is significant, do you need post hoc tests? Yes, but remember, for a repeated ANOVA, it's not called Tukey-Shaffer or LSDT. It is called tests of pairwise comparisons. With practice, this gets easier and easier.